everyone, this video is going to help with, it'd help if you were seeing what I have. 8-4 or comparing two linear, and it may not be 8-4, I say that in every videos, but comparing two linear functions. So what are we doing? What is this idea? What is comparing? It'd help if you can see. I'm not starting out so good. Maybe I should restart. Nah. Okay, comparing two linear functions. What am I talking about? Well, a linear function is something that forms a line when you graph it, right? And it has that m and that b, that slope and that initial value, or rate and y-intercept, or however you want to call them. So when we have two, we're going to compare them. So let's look at some examples. So this first example here has two lines. Let's compare them. Well, they say, all right, well, the rate of change on this one is a -1/4 and the rate of change is a 1 here. So what they're looking at is they're looking at their slopes. So you look for 2 points where it crosses exactly anywhere on this line. So I picked this one and this one. I always start with the one that's lower. And from this one, I go up 1 over 1, 2, 3, 4 in the negative direction. And that's where -1/4 comes from. You can see this is decreasing to the right. That makes it a negative slope. Over here, it crosses perfectly here and perfectly here. So, and perfectly here. So up 1 over 1, or 1. So what can we say to compare these two? Well, one of them is increasing, one of them is decreasing. That's a huge way to compare. This one that is decreasing at a 1/4 is decreasing slowly, as the one is increasing a little bit faster. So you can compare them that way. Let's look where so this is pretty easy when it's negative and positive, and to look at the comparison of them. What about this one? The slope of this one is 2 because you go up 2 over 1. Okay, and the slope of this one here is up 1 over 3, so 1/3. What do you notice about this 1/3 line versus the slope with the 2, the rates of 2? Well, I noticed this one's flatter. Yes, it starts way up here at 1, 2, 2 and I don't know, maybe 2.4, not quite a half. This one starts at 0. So we have different initial values, but also the fraction makes it flatter. And so the higher your rate or your slope, the more steep your line is. And the lower, or the closer to 0 until it hits 0, it goes more horizontal. If it hits 0, it is horizontal. So in this section, you might be seeing something like this. For each city, there is a linear function that describes the temperature in degrees Fahrenheit in terms of the number of hours since 8 a.m. Which function has the greatest rate of change? What does that mean in this situation? So they give us, this is Townhill, and they give us Eastbury. They don't give us, where's the other? I don't know. I'm going to have to move it over here. So they didn't give us both the data on the question, so I was a little confused. So here is, oh, that's because that is Eastbury. Oh, okay. Never mind. I do see. Oh, well, that's all right. We can see it here. Eastbury, I just didn't see it. Eastbury doesn't have a chart. Hilltown does. It says for Eastbury, at 8 a.m., the temperature was 62. Between 8 and noon, the temperature increased by 3 degrees per hour. So when we see that word per, we should think, oh, rate. And we can say the rate of change is 3 because it is increasing 3 from 8 to noon. The Hilltown's rate from 8 to noon, well, this one's going up 2 each hour. Okay, so I was thinking a better way might be to write this as a chart also, just so you can see and compare them. So you could put 8 a.m. and then show the 3 going up 3 each time. And this one goes up 2 each time. So if one has a slope of 3 and one has a slope of 2, which one is getting hotter faster? Eastbury, right? Because it has a higher rate of change. Because they're in a different format, it might be nice if you wrote this out just like this one. 8 a.m., you start at 62, but you're going up 3, 3, 3, 3 from there on out. And that might help you be able to see that. Let's see. What if we had Topoville and they gave you an equation here and look at the rate. It's connected to the H. The 54 is kind of backward, right? We like it in y equals mx plus b or mh plus b, but it's not. So this one also has a rate of change of 2. So we can compare all three. These two have the same rate of change because they're both 2. But this one starts at 54, where this one starts at 62, and this one starts at 62. Where did I get where it starts? Initial value, 54. So there's a lot of things you can look at between those three of them. I kind of botched that question a little bit, but maybe if I paid attention on the bottom of my, this is the solution part, example, but all right, let's look at a couple more rate of change. So the different rate of change and the different, okay, so we can see these ones have different initial values because one's at 2, one's at -1. And then you can see the slope of this one is larger than the slope of this one. So you can kind of look at them and notice the initial point, you're starting at a different spot. Maybe you're going up slower, but you start at a different spot. And eventually they'll be the same here where they cross. This one is like, okay, we have the same initial value. How would I compare? But our rates are totally different. One's negative, one's positive. This one down here has the same rate, but man, they start at a very different place. What else do we call these lines? Parallel. So parallel lines have the same rate because they have to be the exact same, well, what do you call it? Like slope or steepness, but then they start at a different spot. So that's what makes a parallel line. So most of the questions they're going to do is like, which one's growing faster? Let me see here. You might have to look at a chart like this and come up with like, how much is it going up by each time? So from 9 to 4, well, it's not going up, but down or down, right? What is that rate of change? And look at those rates to be able to come up with what it's going down by. So you would be looking at this y value. Make sure the x values count by 1s, but the y values go down or count by something specific. It could be 2s. All right, so really you're just comparing. Need to know the slope. The higher the slope, the more steep or the faster something will grow. Yeah, hopefully this helped you a little. I was trying to think if I wanted to do any other ones. Maybe this one. How can you tell the rate of change of a linear function from a table? How can I tell from a table? You find the change in y when x increases by 1. So all you do is find the subtraction of the y's as increases by 1, find the change in x, and find the value of x when y is 1. Yeah, it has to be A. I was like, oh, there's a bunch of choices here. Because you're finding the change in y over the change in x, which is usually by 1. So what do I mean by that is, look at our chart. It goes up by 1 or down by 1, and we're looking at the change, the difference between these. We're going down 5, and then down 5, and then down 5. Okay, so the rate of change or the slope is -5. Let's see. I think that's all I needed to really cover. This one just kind of pulls in what is the slope, what is that initial value.